Imagine an explosion so powerful it releases more energy in a few seconds than our sun will produce in its entire lifetime. Now imagine that this explosion happens somewhere in a distant galaxy, and for a brief moment it becomes the brightest thing in the universe. Astronomers call these events gamma-ray bursts, and if one happened close enough to Earth, it could change life on our planet forever. In the late 1960s, something strange started appearing in space data. Satellites designed to monitor nuclear weapons suddenly detected intense flashes of radiation. At first, scientists were confused. These flashes lasted only seconds. They appeared randomly, and they were far more energetic than anything seen before. After years of investigation, researchers realized these signals were not coming from Earth. They were coming from deep space. Something out there was producing the most powerful explosions ever detected. These events became known as gamma-ray bursts. This discovery changed our understanding of the high-energy universe, shifting our focus from stable stars to cataclysmic events. To understand why gamma-ray bursts are so extreme, we need to talk about gamma radiation. Gamma rays are the most energetic form of light. They carry far more energy than visible light, X-rays, or ultraviolet radiation. When astronomers detect gamma rays, they know something violent is happening. But gamma-ray bursts are on an entirely different scale. They are the scream of a dying giant or the clash of titans. During a burst, a distant galaxy can briefly shine brighter than every star in that galaxy combined. In just a few seconds, the burst releases an enormous amount of energy. So where does all that energy come from? One of the leading explanations begins with the death of a massive star. Stars far larger than our sun eventually run out of fuel. When that happens, gravity takes over. The core collapses inward with incredible force. In many cases, the star explodes in a supernova, but sometimes something even more extreme happens. The pressure becomes so great that the laws of physics as we know them begin to warp. The collapsing core forms a black hole. As material falls into the newborn black hole, enormous jets of energy blast outward from the poles. These jets travel close to the speed of light, and if one of those jets happens to point toward Earth, we detect it. This is the long burst scenario, a hypernova that signals the birth of a gravity well so strong not even light can escape. Gamma-ray bursts are actually happening all the time. Astronomers estimate that somewhere in the observable universe, one occurs roughly every day, but we rarely notice them. That's because the energy is focused into narrow beams. Think of them like cosmic flashlights. If the beam is not pointed toward us, we never see it. But when Earth sits directly in the path, our telescopes detect a sudden flash. So gamma-ray bursts are among the most powerful explosions. But this raises a disturbing question. What would happen if one occurred close to Earth? About 450 million years ago, the Ordovician-Silurian extinction wiped out 60% of Martian life. Scientists speculate a gamma-ray burst could have been the trigger. If a beam hit Earth today, the immediate impact wouldn't be a physical blast. But the chemical destruction of our atmosphere, the gamma rays would tear through the ozone layer, depleting at least half of it in seconds, allowing harmful ultraviolet radiation to flood the surface. This would kill off plankton and disrupt the global food chain. This invisible killer would leave the planet physically intact but biologically devastated. Furthermore, these bursts are classified into two types, short and long. Short bursts, lasting less than 2 seconds, result from neutron stars colliding. This collision, known as a kilonova, creates not just light, but heavy elements like gold and platinum. Long bursts come from the hypernova collapse we discussed earlier. Both are equally devastating if they are aimed our way. The sheer distance usually protects us. Most bursts we detect are billions of light years away, remnants of a younger, more violent universe. Yet, the possibility remains a haunting shadow. We are essentially living in a cosmic shooting gallery, protected only by the vastness of space. While the likelihood of a nearby burst hitting us is extremely low, these cosmic flashlights remind us how fragile life is. To truly grasp our place in the cosmos, we must continue to look up, studying these flashes to better understand the life cycle of stars. We are observers of the greatest fireworks show in existence, and understanding it is the key to our survival. Most of the gamma-ray bursts we detect occur billions of light years away. That's extremely fortunate for us. Even though these explosions are unimaginably powerful, distance protects Earth from their full force. By the time the radiation reaches our planet, it has spread out across enormous distances, losing its concentration. Instead of destroying planets, the burst simply appears as a brief signal detected by our telescopes on the ground and in orbit. But what if the cosmic alignment shifted? What if one occurred much closer to our home in the Milky Way? Astronomers estimate that if a gamma-ray burst happened within 5,000 to 10,000 light-years mere stones, throughout the consequences could be severe. It wouldn't necessarily blow the planet apart. No, the danger lies in the invisible. It's about radiation. Gamma rays are the most energetic particles. When they strike Earth's atmosphere, they interact violently with molecules high above. This can trigger chemical reactions that damage the ozone layer, our planet's vital protective shield. This shield blocks much of the sun's harmful ultraviolet radiation, and without it, the very definition of habitable changes. If enough ozone were destroyed, the effects could ripple through the entire biosphere, touching every living thing. Imagine a powerful gamma-ray burst aimed directly at Earth from a nearby star system. First, the planet would be struck by a brief pulse. The bursts might only last seconds, a flash in the dark, but the atmospheric consequences could last for years. High-energy radiation could break apart nitrogen and oxygen molecules. This lethal chemistry could create smog on a planetary scale, destroying large portions of the ozone layer. Without that shield, far more ultraviolet radiation would reach the surface than life has evolved to handle. Plants would wither, plankton in the ocean would perish, and many organisms could suffer massive DNA damage. Because plankton form the base of food chains, disruptions could cascade through ecosystems, leading to global starvation. Life on Earth might survive, but it would face a global environmental crisis unlike anything in human history. Scientists wonder whether gamma-ray bursts played a role in past extinctions, like the Ordovician Silurian extinction 440 million years ago. During that epoch, a massive percentage of marine species disappeared. There is still heated debate about what caused it. Some suggest a nearby burst explains why surface dwellers were hit harder than those in the deep. Today, astronomers monitor the sky continuously for these bursts, acting as cosmic sentinels. Space observatories like Fermi are always watching for those sudden, telltale flashes of gamma radiation. When a burst is detected, digital alerts are sent instantly to robotic telescopes around the entire world. Within seconds, these observatories began pointing toward the source of the explosion, racing against time. This allows astronomers to study the afterglow of the event across multiple wavelengths from X-rays to radio waves. Every new detection adds another piece to this complex, high-stake. There's one reason they are frightening: the flashlight effect. Energy is focused into extremely narrow jets. If you are just a few degrees outside the beam, the event might pass completely unnoticed, a ghost in the night. But if a planet sits directly in the crosshairs, the radiation could arrive with tremendous intensity. The difference between safety and catastrophe might simply be a matter of cosmic alignment. We live in a universe of immense power, and our survival is a delicate balance of distance and direction. Ever looked up at the stars and wondered if one of them is secretly aiming a cosmic laser right at us? We have explored the terrifying power of gamma-ray bursts, but now it is time for the final question. Are we living on borrowed time? Is the Earth actually in the crosshairs of a cosmic sniper, or is the universe mostly leaving our little blue dot alone? To find out, we need to do a proximity check. In space, distance isn't just a number. It is our primary shield against destruction. Our stickman astronomer perceives several safe stars. Labels fly by showing distances like 20,000 and 50,000 light years away. But then, we enter the danger zone. For a gamma-ray burst to be lethal, it needs to be within about 10,000 light. Not just any star will do. It has to be massive, over 20 times the size of our sun, to even have a chance. So, what are the odds? Imagine a cosmic slot machine where the symbols are black holes, pulsars, and doomed stars. He pulls the lever. The odds of a nearby hit are incredibly low, estimated at once every 500 million to 2 billion years. Statistically, we are safer than you might think. But statistics don't matter if there's a candidate star already warming up. Enter the most famous suspect, Wolf-Rayet 104. It is located about 8,000 light years away from our solar system. It looks like a mesmerizing spinning pinwheel of dust and light, but it's actually two massive stars locked in a death dance. For a long time, astronomers were worried. It looked like we were staring right down the barrel of its eventual explosion. But modern science has brought us some much-needed relief. Our measurements have gotten much better recently. New data suggests that WR104 is actually tilted about 30 to 40 degrees away from Earth's direction. The universe's aim isn't as perfect as we feared. When it finally goes boom, the deadly jet will likely miss us entirely. Are there other culprits? We have a lineup of suspects, like the famous Eta Carini, another massive star nearing its end. While these stars are massive and dying, None are currently confirmed to be pointing exactly at our front door. Gamma-ray bursts remain the undisputed kings of cosmic violence, but for now, we seem to be safe in our quiet suburbs. The best thing we can do is keep watching, keep learning, and appreciate the incredible universe we call home.